Welcome to this video on tube bending. For this exercise we're going to use a annealed copper tube and it's 1/2 inch in diameter. We'll have a look at the bend that we're going to do straight along the bottom, up between that obstacle there, that slot, and along then to the right hand side to the flared fitting. Tools that we're going to use: rigid tube bender, tube cutter, a flaring tool, some copper tube of course, tape measure, and some compression fittings. So we've got 1/2 inch olives there, brass and nylon. So if we have a look at the two, we're going to do two different fittings. We're going to do a flared fitting and a compression fitting. The flared fitting, as you can see, has got the tapered nose on it, the one that's fixed to that jig. The one that we're going to manufacture will have that flared or trumpet end on it, and that will fit over the brass fitting, and then the backing nut comes up, screws onto the fitting, and the tighter of course that we screw that on, the more it presses the soft copper tube, the annealed copper, onto the face of the harder brass fitting, and that's what forms the seal between the two components. The compression fitting, let's have a look at it. Main part of the compression fitting is the olive. Here we'll be using a nylon olive, and of course the copper tube, and the copper tube just fits up inside that fitting. The two together is what we really want. Nylon fitting just slides over the end of the copper tube. The copper tube goes up into the fitting, the brass fitting, and then the backing nut comes up behind the olive, and again the tighter we pull the spanners up or pull that nut, backing nut up, the tighter it fits, squeezes the olive between the brass fitting and the copper tube, as you can see there, and that's what forms the sealing between the two components. To check how much tube to cut off the roll, measure two horizontal distances from the compression fitting just to that center gap on the top section, from the flared fitting to that center gap, and then the vertical height up to the center of the flared fitting, and that will give us an approximate of what we need in regard to a length of copper tube. It works out about 700 millimeters of tube to be cut off the roll. Just making a mark on the bench, use a tape measure, put another chalk mark at 700, because we can't pick up the copper roll and just grab hold of the end of it and pull off a stretch of pipe. The annealed or soft copper will just kink and get all badly out of shape. What we need to do in a specific way, and this is how we do it: put the copper tube down on the bench on the mark, hold your hand on the end of it, and then roll it back from there. Just roll it straight back along until you've covered enough distance to use a tube cutter, and we'll cut off the 700 millimeter length. If you had about 5 meters to cut off, you could put it down on the floor, get someone to stand on the end of it or put a weight on the end of it and just roll it back along the floor. You get a nice straight run of pipe that way, or run of tube. We'll just I'll allow an extra 20 millimeters, so I'll cut that about 720 millimeters. And we'll just use a tube cutter, and that'll give us a nice neat end on the tube. There's a little deburring blade on the back end of the tube cutter. Just insert that into the end of the pipe and twist around, and that will give a nice chamfer. Just clean up any rough burr on the inside edge of the pipe. Try to get, since we're looking for nice straight runs on this tube work that we're doing, just sight up the tube. Any little kinks or bends that are in it, try to straighten them out a little bit, as much as you can. It's going to make the finished job look that much better. Insert the 1/2-inch copper tube up into the compression fitting. We need to get a chalk mark here just at the center of that gap. Just eye it up, be as accurate as you can with your eye. And we need to do a 90-degree bend on that. Next thing we'll do is we'll set the rigid tube bender up. We're just going to put it in the vise. You can do this by hand, but by putting it in the vise just allows you so much more control over it. Makes the bending and the settings that you have to do that much easier, especially if you're using a long length of tube and awkward shapes and sizes on it. If you have a look around the circumference there, it starts at 0 at 12 o'clock, then 45 degrees around to your right, and 90 degrees. We want to do 90 degrees, that's 0, 45, and then around to 90. That's called the former handle there. And that's called the link just behind there, and this where my finger is 90 degrees 0, 45 and 90 degrees just there. Now we're doing a 90 degree bend. We're working from left to right. By that I mean the compression fitting is where my left hand is. And then we're doing, so that chalk mark gets set on the 90 degrees on the link. That's a little clamp. We swing that around just to hold the copper tube in position. We bring the 0 to 0, match up the two zeros there on the former. We're going around to 90 degrees. Get the former handle and push down steadily past the 45 degrees on down to 90. Probably go just a little bit more, degree or so, just to allow for a little bit of spring back on the tube. And then we take that out and let's have a look at it in the jig, see how it works. Put it up into the compression fitting. And that's swinging there quite clearly. Just check it with the compression nut on. Make sure there's plenty of pipe going up into the fitting. Now we have to work out where to put the chalk mark for the next 90 degree bend. Just taking the vertical height up to the center of that fitting, to the center line of the fitting. Transfer that across to the tube, just hold it as square as we can. And remember, we're looking for nice straight lines. Put the chalk mark on there. And put it into the tube bender as I'm holding it at the minute. Just transferring that chalk mark around so I can see it. Put it into the tube bender. Keep the compression fitting to the left hand side. We're bending from left to right, progressing from left to right. Putting the clamp in position. Now just sight up that pipe to make sure it's perpendicular, nice and straight up and down, so the next 90 degree bend will be parallel to that. Bring the 0 to the 0. On the former handle, press down. Just have a look at that again from another view. Just lining it up with the 90-degree mark on the link. The little clamps in place, checking that the tube is straight up and down. Bring the 0 on the former handle to the 0 on the former, and then press down slowly, steadily, 45 on down to the 90 degrees, and just a fraction past that. Undo the clamp and let's check the completed bends and see how that lines up with our fittings. Now I allowed a little bit extra when I cut the tube off the roll, so I'll just trim that, put a chalk mark. I'm putting the chalk mark opposite that chamfer on the flared fitting, on the nose of the flared fitting. Get the tube cutter and we'll trim that pipe off. Just about to use the flaring tool. We'll have a closer look at it later on. At the minute what we're doing is there's a clamping section, putting the 1/2-inch copper tube up into the 1/2-inch slot in that clamping device. Screw in the T-handle on the side, and that clamps the bridge part onto the clamp and holds the copper tube, clamps the copper tube nice and tight. Here we are, have a closer look at it now. You can see on the top it's got that chamfered section that's going to form the bell mouth on the end of the copper tube. We look for the 1/2-inch, that's a 1/2 inch, the third one down. I'm just using a piece of scrap copper tube to show you this close up. Put the copper tube in there. Leave it just up a little bit above the surface, probably 2 or 3 millimeters. Bring the bridge piece along. You can see the dimples on the side of the clamping tool, and need to make sure that that little T-bar is directly over the dimple on the 1/2-inch. When you're satisfied that that is correct and the tube is just proud of the surface by about 3 millimeters, screw in the T-handle. That'll clamp the whole assembly nice and tight. And now we just screw down the handle on the bridge part. It's inside there is a something like a lathe center, you might describe it as, which is on an eccentric and just rolls around and pushes the soft copper tube out into the shape of that chamfer, which gives it that nice flared shape. Just release the clamp, and there's the fitting. You can see it's got that nice bell mouth on it, and that will sit over the fitting. When the backing nut is on, That will seat in nice and tightly and form a good seal. It's important when you're forming the flare, well, we're just having a look at the compression fitting here. So put the backing nut on, then the olive. And this isn't the actual tube at the minute, it's just again a piece of scrap tube I'm just using to show you a close-up of what we're going to do. We'll bring the backing nut up and screw that up nice and tight to lock it into position. Tighter we bring up the backing nut, the more pressure we put onto the olive, squeezing it tightly around the copper tube and forcing it into the brass fitting, forming the seal. The compression nut, the compression fitting, you can see the chamfer clearly on the end there. The copper tube will sit over it like that, and the backing nut will come up. We screw that backing nut on nice and tight. And that will force the soft anneal copper tube onto the harder brass fitting, and between that those two faces will form the seal. Once we've got it fixed into the jig or the test rig, we're going to put on the pressure tester. It's a water pressure tester. Just making the connection. Just snip that up. Going to test it to 10 bar, 150 psi approximately. So if there's any looseness between the fittings, it will certainly show up. Just screwing in the bypass valve there, which is going to direct the pressure from the pump now, the hand pump, into the rig. You can see that a substantial leak coming from the flared fitting. Get the spanner and put a little bit more pressure on that. Just put some more pressure on the backing nut. Try the pump again. It's still leaking there. A little bit more pressure onto the nut. And this time it's holding no leaks at 10 bar. Just wipe away the water to dry off the fittings and try it again, just to make sure there's no damp or wet coming out of the fittings. Just check the compression fitting. And that's okay. Just open the bypass valve, release the pressure. Just going to cut the end off this pipe, cut the flared fitting on, because we're now going to put another 90-degree bend to the left-hand side of this tube assembly to go into the flared fitting that's just halfway along the rig there. Now have a closer look at the tube cutter. It's got 2 rollers in the top end of it there, and it's got the cutting blade just on the bottom. The tube sits in between the two. The tube just sits in between the 2 rollers. That puts the pressure, pivots the pipe, puts the pressure down onto the rollers. And as we rotate it and screw the top handle in slightly as we go, every round, just screw it in, quarter turn, half a turn. Don't overload it. You can break the blades, maybe not on the copper tube, but certainly on steel tubing, by putting too much pressure onto the cutting roller. It's hardened and it can shatter. And that's the deburring blade just on the back of the frame there. You put that into the end of the pipe and just rotate it around, and it will scrape out the inside of the tube and give a nice chamfer on that leading edge there. Now, next thing we have to do is try and get a mark off the center line of that flared fitting on the side along to the length of copper tube that I'm holding. To do that, I'm going to use an engineer's square. Just put the square along the pipe and get the blade directly opposite or in line with the center of the flared fitting, and then put a chalk mark just out on the copper tube. And that's where we're going to put a 90-degree bend. When you put the tube into the former, the tube former, just be careful of the orientation of your bends. Again, we're working from left to right. So the compression fitting is to the left-hand side there. And then we need to just make sure that we've got the 90-degree bend going in the correct direction, in this case down, with the other bend lying horizontal on the former. Just put the clamp into position to hold it, 0 to 0, and then down through to your 90 degrees. Just put the compression nut on, have a look at how the fitting lines up. Pipe needs to be trimmed a little bit. So we just put a chalk mark, again, just at the outside edge of that chamfer, the largest diameter of the chamfer. Opposite that, get the tube cutter, and we'll trim the pipe to that. Again, just check the bends to make sure everything is in line. Just checking that is nice and square, because what we're trying to achieve is nice straight lines. Put the backing nut on before we make the flared fitting, which I'm doing there. Put the 1/2-inch copper tube into the clamping tool in the 1/2-inch hole. With the flare down, put it back into the rig. And just check how that lines up. Just nip that into position. Screw in the bypass valve, and we will check the pressure again. We want to take it up to the 10 bar like before, and hopefully have no leaks. We're obviously on the 10 bar there. (150 psi). Happy with that. Release the bypass valve. Releases the pressure. That's the job done. But just eyeing it up to make sure that those lines are nice and straight, 2 directions. Just check it. Everything's not. We want nice parallel lines. And that completes the task of tube bending, and thank you for watching.